This is Jenny Kunkel, and in this video we are going to take a look at outer joins and cross joins in Oracle. We'll do a quick review of our Muroc SQL Server slide for outer joins before we go over to SQL Developer and start working there. For our outer joins, we have the left, the right, and the full outer join. The left is going to include all the information in the leftmost table, and then the information from the right table where there's a match between the right and the left. Then on our right join, we're going to be including everything from the right table and then information from the left table where there's a match between the left and the right. When we have our full outer join, then we're going to be including both tables, all the rows from each table, and fill in the information that matches between those two tables. Switching over to SQL Developer, we are going to be using the HR connection, and this has tables for our job and jobs history. So if we go and try to create a diagram for this, we're going to do File, Data Modeler, Import, Data Dictionary, select HR as our connection, HR as our schema, the tables, job and job history, next, finish, and we have our diagram. And we can see that we have a connection here based off of the job ID between the two. So that is how they are connected between the job history table and the jobs table. We have job ID, job title, minimum salary, maximum salary. In the jobs table, we have start date, end date, job ID, and department ID in the job history table. We are going to select the job ID, job title, minimum salary, maximum salary, employee ID, start date, end date, and then the department ID. From those tables, we're going to do a left join to begin with, and we're going to use the ANSI standard to start. So if we go over to our HR, we're going to start by selecting the job ID, and we'll put in the qualifiers in a little bit. This is going to be the job title, the min salary, max salary, employee ID, start date, end date, and then the department ID. We're going to be selecting from the jobs table, giving it an alias of J. We've already looked at the fact that we can't do the as J. It gives us an issue. We have to just put J there. Instead of doing that as keyword in Oracle, we have a left join that we are going to do on the job history table with an H for the alias, and we're joining on the job ID. We're going to come back and put in our table alias references here. So this is going to be J dot, J dot, J dot, J dot. Our employee is going to be retrieved from our history. We have an H dot for the start date, H dot for the end date, and H dot for department ID. Before we run this, we have a couple things that we probably should look at. One of them being the count of the number of rows in the jobs table. If we look at that, this is going to give us a count of 19. if we do an inner join on this, and I'm just going to copy this and essentially do an inner here, notice that we have 10 rows being returned, and in this case we have the job ID being duplicated on 2 of the rows. And if we were to think about the fact that we have 19 rows in our jobs table, but we have 2 duplicates when we join, we should end up with 21 rows when we are doing the left join. So let's go ahead and run this. And we do, in fact, see that we have 21 rows being returned where we have the AC account 2 times in here, and then we have the ST clerk in here 2 times as well. Now, where we have matches between the 2 tables, we have our employee ID, start date, end date, and department ID filled in. Where we don't have a match in the job history table, that's where we're seeing the nulls. We can go ahead and switch this from the left outer join to the right outer join. And we also need to take into account how many rows we have in our job history table. This is going to be a factor in determining how many rows we would expect. So we have essentially 10 rows being returned from our history table. If we run this with a right join, we expect that we should get 10 rows back. We wouldn't expect to see the duplicates because we have the job ID and the date combination that already exists within the job history table. So we would expect to have the exact number of rows returned, and we did. And we can see that we have matches for everything that's in that job history table to the jobs table. It's only when we have the jobs table being matched to the jobs history that we do not have matches occurring. Now, if we go ahead and do a full outer join, this is going to be where I can go ahead and get everything. This is going to return the 21 because that's going to essentially compensate for everything, so we're going to get the same number. Now, we've also looked at the implicit syntax for creating our SQL statements for our inner joins. With SQL Server, we cannot do the implicit outer joins. However, in Oracle, we can do the implicit for our left joins and our right joins, and then we can do a union statement with our left and right join to come up with the results of the full outer join. It's kind of kludgy, but it does work. So let's take a look at what that looks like. So I'm going to copy my original statement here and paste it down here. This is what we're changing. I'm going to get rid of all this other stuff here. And this is going to be where we're joining the jobs in the job history table. And we're doing this where we have our j.jobid equal h.jobid. And at this point, if we would run it, it would essentially be an inner join. So how do we make it an outer join? Well, it's kind of goofy, and it is such that if we are going to be doing a left outer join, we want to put a parenthesis plus sign on the side that is the opposite of the table that we want to join on. So if I want to do a left join, that's going to be on the J table, then I would put the plus sign on the H side and then execute it, and I should get the same number of results back, which is 21, that I would get if I was actually executing a left join here. So if I execute that, I get 21 as well. Now, if I decide that I want to do a right join, I would come down here and I would move my plus sign to the opposite side. So it's going on the opposite side that I want to do the right join on. So my right table is my job history, which is H. So I put it on the opposite side and I can execute this. I'm going to get my 10 records back, the same as if I would execute this statement here. Now, if I want to do a full join, it's going to be a combination of the union statement of this with the union, copying this down, changing this to the opposite side, and this should give me essentially the same as a full outer join. We have things populated, things not populated if we did the full. We essentially see the same results, it's just not in the same order. So that essentially shows us how we can do implicit syntax using the outer join in Oracle. This is not something that we can really do in SQL Server, and probably it makes more sense to use the ANSI standard, although in Oracle shops you'll probably still see this type of syntax being used for outer joins. Now the last thing that we want to talk about is where we can do our cross join. This is essentially the same as the Cartesian product that we want to create. We have to be a little bit careful. We have small tables, so we can do this. I'm going to just change this to a cross join and then go ahead and remove the on condition. This is going to give me that Cartesian product. So instead of having 10 and 19, when I get done with it, I should have 190 because it's the 10 rows times the 19. That's going to be 190. It would be the same thing if I just went ahead and on my statement here, got rid of everything and executed this. This is going to give me a Cartesian product and return the same amount of rows because I'm not qualifying by anything. So this essentially is the Oracle outer join as well as the cross join.